Okay, Year 10, we're just looking at an answer video for your most recent test. So we'll go through. The first question was matching curves. So there were different strategies you could have done. I would have started, say, like you got. Oh, sorry. Put that back. So I would say start with the circles. You had two circle equations: x squared plus y squared, x squared plus y squared. This one had a radius of 3, so that matches that one. This one had a radius of 1, so it matches that one. Okay. There's only one exponential graph, and so the only exponential graph was that one, so that was a B. We might do the straight lines next. The straight lines are those two there. That's a straight line because it's got x to the power of 1, and where else? That one is a straight line because it's x to the power of 1. They've both got negative gradients. This one's going through the origin, so it had to be F, which means that the other one had to be A. So then we're left with the three parabolas. So this one is a concave down parabola, so you need a minus sign in front of it, and the only one with the minus sign in front of it was that one. Okay, and then we're just left with two more to go. This one is going through the origin, so we need one that has nothing at the back of it, which is that one's got nothing at the back, so that one is the D, which leaves this one as the C. Okay, come across when you're ready. Okay, describe what parallel lines. Okay, you've got to have any description, but basically at some stage you had to say the gradients are the same. Somewhere you had to say the gradients are the same. Describe what perpendicular lines look like. At somewhere you had to say they intersect at 90 degrees. Okay, so you have to have something, you have to use those bit of information. You could add other words, but basically that was the key part of that answer. Okay, so if they're parallel, the gradients are the same, so as long as you had 1/6x plus something, you were fine. Also with up this on here, you didn't have to, but you could have said that the gradients multiply to give -1, because you need to know that for this one. So this one, you flip it upside down and make it a minus, and then you just have to have something with -6x in front of it. Come across when you're ready. Okay, so this is a cubic. So we've got x times x times x. So we've got x cubed. So the shape had to be either that one or that one. And this one's a positive, so it had to be that shape. Okay. So the x-intercepts are from that bracket, so we've got 1 from that bracket, so we've got 2, and from that bracket we've got 3. So they're the three x-intercepts. The y-intercept will be when x equals 0, so we've got 2 out the front of -1, -2, and -3, and that multiplies to give -12. So 4, 8, 12. And so you just have to finish off the graph. So we're going to go up, down, and then up. So something like that. So we've graphed the line, select an appropriate scale, and label the axes y and x. So we've done that. Name two key features of how the graph differs from y equals x cubed. Well, you have to know that y equals x cubed is not a roller coaster. It has that sort of shape. So it has no turning points. It has what's called a point of inflection, but you didn't have to know that. So how does it differ? Well, one of them has a y-intercept of -12, the first one, against y-intercept of 0. The x-intercepts were for this one were 1, 2, and 3 against x-intercept of 0. You could have said there were 2 turning points. This one against no turning points. So you had to say something along those lines. What does the index above the x tell us about the shape of the graph? Well, it gives us the general shape, obviously. But for instance, if it's an even power, it has to finish in the same direction. It could have roller coasters, but basically an even function has to finish in the same direction. An odd function, an odd power, has to finish in different directions. What else could you say? So the index tells us the general shape, but you have to mention this sort of stuff about even powers and odd powers. Like for instance, if it's power 2, okay, it has one turning point, but a power of 3, it could have no turning points, or could have 2 turning points. It has it generally has one less turning point than the power, but it could have no turning points, like for instance that one here. So you could mention something about turning points, but you have to be very specific and not generalize, and to say it's not always one turning point less than the power. Sometimes it's not. Okay, come across. Okay, this one was hopefully a bit more straightforward. It's concave down. The x-intercepts are 2 and -6, and the turning point is up there, so it's -2, 16. Okay, come across. Okay, so this one is a parabola. It's an even power, which means it has to look like that shape. So we'll do the 0, 1, 2 calculations. So 0 squared is 0 plus 2 is 2, 1 squared is 1 plus 2 is 3, 2 squared 4, 4 plus 2 is 6. And from the symmetry of the shape, these numbers have to be the same. But for the people who just think putting numbers on their calculator is the best way to go, if you put -1 squared plus 2 on your calculator, you get 1 plus 2, so the answer is 3. But if you put -1 and you press x squared, you get -1 because the calculator doesn't square the number, it does -1 squared. So those people that had like -1 and +2 or whatever, it's because you weren't thinking about what you were trying to get. And so you end up with, I'm not going to draw it accurately, but you have to end up with a shape like that. It's a parabola. Okay, come across when you're ready. Okay, so this question was a good question in terms of just straight interpreting. Find the initial height of the bird is 3 meters. When does the bird first enter the water? 1 second. How long is the bird underwater? It's underwater between 1 and 3, so it's underwater for 2 seconds. How deep did it go? 1 meter, or accepted -1 meter. Calculate the height at 10 seconds. Well, the height is given by that formula there. So height equals 10 squared minus 4 times 10 plus 3 equals 100 minus 40 plus 3. So the height is 63 meters. And this last part was a little bit vague. What's the total distance travelled by the bird? Well, it starts at 3. On this diagram, it starts at 3, goes to 4, but it's going down 4 meters and then up 5. So from the diagram, it's 9 meters. I also accepted 8 meters, but you had to say in 4 seconds. So it went from there to there with a -1. But the answer that was probably the best answer was taking into account that it's going to 63 meters. And so when you added the distances travelled, so it's going 3, from here, from 3, it's going up another 63. So it's going 3, 4, 5. So it's going 5 meters to there, and then it's going another 63 meters. So the answer is actually 68 meters. So either of those answers, but with this one here, you had to say in 4 seconds. So that they're all correct, but this one here, you had to say in 4 seconds. Okay, next page. Okay, go to parabola again. Does the point lie on the line? You must verify. So that's the x. So x equals 1. So y equals 1 squared minus 2 equals 1 minus 2 equals -1. -1 is not the same as 3, so the answer is no, it's not. The parabola at y equals x squared moves up 6 units, so it's just y equals x squared plus 6. The parabola at y equals x squared moves down 5 units, so we've got x squared minus 5, and then it's reflected in the x-axis. So we've got that, and then it's going to flip upside down. So the final answer will be 5 minus x squared, because it's been flipped. Okay, equation of the circle. Okay, we've got a circle x squared plus y squared. So we've got no brackets, so the center is 0, 0. The radius is the square root of 169, which is 13. Find the value of y when x equals 3. So we've got 5 squared plus y squared equals 169. Y squared equals 169 minus 25 equals 144. And so y equals plus or minus the square root of 144. So plus or minus 12. Draw the circle. You have to be fairly close to a circle. 13, 13, minus 13, minus 13. That's it. Oh, and put the y and the x on the axes. That's it. Okay, find the coordinates where they intersect. So this is a little bit harder. So we've got x squared plus y squared equals 5. So, and we've got y equals 2x. So if y equals 2x, then y squared equals 2x squared, which is 4x squared, and then make the substitution. So x squared plus 4x squared equals 5. So 5x squared equals 5. So x squared equals 1. So x equals plus or minus the square root of 1, which is plus or minus 1. So the coordinates, two answers. So when x equals 1, x equals 1, y equals 2. When x equals minus 1, y equals minus 2. So the coordinates were 1, 2, and minus 1, minus 2. Okay. A lot of people, I think, made errors. They tried to make, because they had y as a subject there, they tried to make y as a subject there. So the most common error was they had y squared equals 5 minus x squared, and then they said y equals the square root of 5 minus x, and you're completely wrong because you can't square root separate numbers. Okay, so you can't do that. So the easiest way was to make y squared the subject and then make a transfer. Okay, last page. Okay, sketch and label. Okay, 4 to the x. Okay, so I'm just going to do this roughly. Okay, 4 to the x goes to at 1, and then 4 to the 1 equals 4, so it's goes something like that. So that's y equals 4 to the x. Minus 4 to the x is the complete opposite of that, so it goes the opposite way. So something like that. Again, you might be more accurate, hopefully. And 4 to the minus x is going to go the opposite way, so it's going to be decaying, so minus 1 is 4, so it's something like that. You've got to show a bit more accuracy. So graphed, show at least 2 points. So obviously you can show the y-intercept, and then I was showing at 1 it was equal to 4, at 1 it was equal to minus 4, and at x equals minus 1 it equals positive 4. So they're my points. Okay, consider the transformation graph of that. What transformation occurs to do that? Well, that's just a reflection in the x-axis. For 4 to minus x, it's a reflection in the y-axis. Which graphs intersect? Well, those two intersect. So 4 to the x and 4 to the minus x intersect. What are the coordinates? Well, it's 0, 1. Considering y equals 4 to the x, write one sentence as x gets smaller. So just remember, 4 to the x looks like that. So as x gets smaller, as x gets smaller, so we're going that way, the function decreases. So 4 to the x gets smaller. It actually approaches 0. Approaches y equals 0. Okay, and that's it. That was our last page. Okay, thanks, bye.